This video goes along with number 42 from the final review packet. We are asked to find the exact value of sine of half of theta given some other things about the angle. So from the formula sheet, sine of 1/2 theta looks like this, plus or minus the square root of 1/2 times the quantity 1 minus cosine of theta. They have x, but I'm just switching to theta because they're giving us info about degrees. Now, what we need to do is, one, just plug in this cosine of theta that we're given. So we'll put 4/5 in here eventually. But we also need to decide, is this positive or negative? We don't leave that as part of the final answer. We have to choose one. Sine of an angle only has one output. So let's do the work for that first. Because they tell us theta is somewhere between 360 and 450, which is actually a kind of an unusual way to list quadrant 1, but you'll see what changes when we make some adjustments here. We don't actually care about theta, though. It says find sine of half of theta. So if theta is in that interval, half of theta is between, well, let's just divide all parts of that by 2. It's somewhere between 180 and 225. So let's think about where that falls. 180 and 225 would be in quadrant 3. And only tangent is positive. But because we're asked to find sine of something in quadrant 3, we're going to choose negative. So when we talk about this plus or minus, I'm going to write here my next line, negative square root of. So when I'm all done, my answer should be negative. So think about a multiple choice question. Maybe you can eliminate some options right away. Now from there, let's just plug in this 4/5, not for theta, but for cosine of theta. So take a little look here. We are told cosine of theta is 4/5. So that whole thing comes out, 4/5 goes in its place. This would be the wrong way to do it. We don't want cosine of 4/5. 4/5 is not the angle. And then you just simplify that. I'll leave that to you. You end up getting either negative square root of 1/10, but rationalized, that would look like negative root 10 over 10. But again, multiple choice, even if you have a decimal equivalent, I think you'd be successful finding its match.